Have you ever wondered if there is more to life than meets the eye, or if we are actually alone in the universe? Imagine for a moment that the James Webb Space Telescope confirms our existence within a black hole. Come study this startling revelation that will make you re-evaluate everything you believe to be true about the cosmos. What precisely are black holes, then? They resemble something from a bad dream. Although you may have seen them in science fiction films, the reality that they exist is considerably more unsettling. Imagine a star several times more massive than the Sun, all crammed into a sphere the size of New York City. That is what black holes in space are. Enormous amounts of matter compressed into a very small area. Nothing can escape the force of gravity, not even light. It is so strong. For years, black holes have captivated scientists who have studied these gigantic, dense space objects that have the ability to trap light. General relativity, the theory put forth by Einstein, predicted the most popular hypotheses concerning black holes. In essence, a tiny, dense core is left behind after a large star dies. A black hole forms when gravity triumphs over all other forces, and the mass of this core is several times that of the Sun. Since black holes do not produce light, it is difficult to detect them, but scientists have developed methods to infer their presence by analyzing the impact they have on neighboring matter. For example, in the process of accretion, matter is drawn towards a black hole if it passes through an interstellar cloud. Furthermore, a typical star may be ripped apart and release X-rays when it approaches a black hole too closely. Black holes also have a big effect on the environment around them. They can eat neighboring stars, create powerful gamma bursts, and even change the rate at which new stars develop in some regions while slowing it down in others. However, whence do black holes originate? Imagine this. Stars that were once bright and sparkling finally explode in a huge explosion known as a supernova. Black holes erupt from the ashes of these fallen giants. Smaller stars die and become neutron stars, but the majority of black holes are created by huge stars that have reached the end of their life cycle and burst into a supernova. Although they are quite dense, light cannot be trapped by them. On the other hand, a star that is many times as massive as our Sun will eventually collapse due to gravity, creating a black hole. Something weird occurs close to the surfaces of these enormous stars as they collapse. Time begins to act strangely. Viewed from a great distance, time seems to slow down as one approaches the event horizon, the final barrier separating matter from the black hole. It appears as though the star's clock is ticking off time differently than our own. Every now and then, two smaller black holes meet and combine to create an even more deadly and massive black hole. When a black hole and a neutron star combine, they form an unfathomably large and terrifying object. For quite some time now, scientists have struggled to comprehend the scope of these cosmic mysteries. There are two types of black holes, supermassive and stellar. In the context of black holes, small is a relative term. Remaining parts of big stars, known as stellar mass black holes, can resemble the Sun in size, with some up to 20 times its mass. The estimated number of black holes in the Milky Way alone is between 10 million and a billion, which is an incredible quantity that can eat anything in their path. And that's not all. There exist even more enormous black holes that dwarf the Sun by millions or even billions of times. The centers of huge galaxies, like the Milky Way, are home to these titans. They attract everything toward them like a huge vacuum. The great physicist Stephen Hawking devoted his life to studying black holes and provided many insightful observations, albeit he was unable to validate several of his hypotheses because the necessary technology was not available. But there is cause for optimism. Everything is changing because of one scientific tool, the James Webb Space Telescope, JWST. Its purpose is to investigate the depths of our cosmos. I can assure you that the JWST is not your typical telescope. Rather, it is a work of engineering genius and evidence of human creativity. Though we have launched other space telescopes in the past, they have not performed nearly as well as this one. The Hubble Space Telescope, which has diligently served us for years, now seems like a simple space toy in comparison to the JWST. How much does this astronomical marvel cost? A startling $1 billion. You did really hear correctly. To make this project a reality, over 300 universities contributed significantly, and NASA, the European Space Agency, and the Canadian Space Agency work together. But we shouldn't undervalue the dangers involved in such a huge undertaking. The JWST is exploring new territory, pushing the boundaries of our understanding and visiting destinations we could only imagine. NASA recently revealed that the telescope has enough fuel to run many times longer than its initial mission life expectancy, following a successful launch. The JWST has reached several noteworthy milestones since its debut. It took it more than 1 million miles to get to its permanent home in orbit around the Sun. The telescope's gigantic primary mirror and enormous 5-layer sunshield, which had to be folded to fit into the launch vehicle, were successfully deployed throughout the journey. The telescope has now been calibrated and adjusted by NASA, making it nearly ready for full operation. The announcement by NASA that the James Webb Space Telescope had taken its first pictures of starlight was one of the telescope's most thrilling features. The telescope's first picture was of a star known as HD 8446. The 18 mirror segments aligned on the main mirror produced a collection of 18 scat brilliant spots from the star's light. Later, NASA published another amazing photo of HD 8446, combining 18 unfocused copies of the star into a purposeful hexagonal pattern. The observatory will begin the process of stacking photos, placing 18 images on top of one another to create a single, distinct vision, after fine-tuning the component parts of the primary mirror. The JWST will help scientists study the early phases of the cosmos following the Big Bang, concentrating on what happened after the first stars formed, a time known as the epoch of reionization thanks to its cutting-edge technology. This epoch describes the time when radiation from these early stars reionized, or charged neutral hydrogen. It means gazing back billions of years, an accomplishment that can only be done with a massive telescope such as the JWST. Additionally, the telescope will aid in the discovery of exoplanets, which are notoriously difficult to find because of their interactions with their host stars. The JWST's powerful capabilities allow it to investigate these planets more closely, including photographing their atmospheres in certain situations. Scientists may be able to anticipate whether a planet is habitable more accurately if they have a better understanding of the planet's atmospheres and developmental environments. Researchers look at universes in addition to galaxies to learn about the large-scale distribution of matter. Thus, we are able to observe the evolution of the universe. Over billions of years, the spiral and whirling galaxies that we see today evolved from a variety of forms. Examining the earliest galaxies to learn more about their evolution is one of the main objectives of JWST. Scholars are also attempting to determine how the current mechanisms that form and organize galaxies came to be, as well as how we came to see the collection of galaxies that we see now. But above all, the James Webb Space Telescope will enable us to tackle the most important of all questions. Do we inhabit a black hole, and are we the only beings in the universe? In 3 active galaxies, the JWST has already been monitoring the area and discovered something interesting. Substances known as polycyclic aromatic hydrocarbons, PAHs, are hiding around those massive black holes. From distant galaxies to comets in our solar system, these carbon-based particles, with their ring-like formations, are like the Goths of the universe. They are fascinating not just because they might be the building elements of life, but also because they help astronomers monitor the development of stars. These PAHs are activated by intense radiation and release infrared light, which the mid-infrared instrument on board the JWST, called MIRI, can detect. Usually, this emission indicates the presence of nearby hot, young stars. The shocking revelation now comes from Oxford University astrophysicist Ismael Garcia Bernard, who took the audacious decision to study 3 distinct galaxies, NGC 6502, NGC 731, the eerily well-known Stephan's Quintet, and NGC 749. These systems are deep in the darkness, millions of light-years away. Your hair will stand on end when you learn what Garcia Bernard found out. He noticed that there were a lot of PAHs in the areas where black holes rule. It sounds fascinating, doesn't it? The really scary part comes when you realize that the radiation from those enormous black holes changed the composition of the PAHs, making them bigger and more electrically neutral versions of themselves. The tiny, electrically charged PAHs disappeared into the shadows, as though they were eaten up by the darkness itself. But hold on, there is a ray of hope. The bigger PAHs made it through, taking cover in thick clouds of gas. It's as though they have found a shield of their own to shield them from the terrifying wrath of the black hole. You may be wondering why this terrible turn of events is significant. For space scientists, however, who depend on PAHs to track star formation, this is a serious problem. Electrically charged PAHs are abundant in star-forming areas and can be destroyed in close proximity to black hole populations, making it difficult to pinpoint the star's birthplace. Our determined space scientists, nevertheless, aren't giving up. Garcia Bernard is committed to exploring these dark cosmic abysses with his crew. In order to learn more about these peculiar galaxies and their peculiarities, they wish to examine more of them. How these large-scale PAHs endure in these conditions. Their goal is to discover the unique characteristics of PAHs that are hidden in the accretion zones surrounding black holes and galaxies. Hey, that data is essential to comprehending star formation and the long-term evolution of these unsettling galaxies. But hold on, the James Webb Space Telescope has produced yet another incredible finding that really takes the cake. Prepare yourselves for some terrifying news. The JWST has discovered what may be the universe's oldest black hole. This enormous object is an extraordinarily huge black hole with a mass 10 million times greater than that of the Sun. By examining dim bursts of light that stretch back to the very beginning of time, the JWST was able to find it. Situated at the center of a newborn galaxy, 570 million years after the universe was formed, lies this dim yet sinister discovery. Black holes that are considerably older may be hiding in the depths of space, according to cosmologists. The thought of what more atrocities might be out there, just waiting to be uncovered, is both alluring and disturbing. There is no doubt that the James Webb Space Telescope is giving us a look into the deepest recesses of the cosmos, and the discoveries we are making are nothing short of astounding. The scientific community has been rocked by the finding of the universe's earliest black hole. This enormous creature might be one of the many black holes that existed in the early universe, which started at 100 million years after the Big Bang and lasted until the universe was only a billion years old. The sheer quantity of these black holes and their formation to such enormous sizes confound cosmologists. The most recent black hole was found by researchers who published their results on the preprint server AR14. The paper has not yet been subjected to peer review. Astrophysicist Rebecca Larson, the principal investigator, thinks there are still a lot of black holes out there to be discovered. She works at the University of Texas at Austin. She clarified that we are now able to study cosmic history in a way that was previously unthinkable thanks to the James Webb Space Telescope, and she is eager to see what more we will find. With the James Webb Space Telescope tasked with revealing the inexplicable, who knows what other mind-blowing cosmic shocks lie in wait for humanity over the wide reaches of space. There are many mysteries in the universe that are just waiting to be discovered. We get a little bit closer to solving its enigmatic and majestic mysteries with every new finding. Black holes keep revealing the fine details of our universe as we explore farther into space. They can form from the collision of neutron stars and other compact objects, in addition to the demise of dying stars. Critical phenomena like gravitational waves, ripples in space-time that observatories like LIGO have detected, are caused by this collision of celestial entities. These waves shed light on the violent processes taking place in the universe, such as the formation of black holes. The search for dark matter, a mysterious element that makes up a sizable amount of the mass of the universe but is still elusive to present observational techniques, and the understanding of black holes are intertwined. Dark matter may be explained, according to some scientists, by primordial black holes that originated shortly after the Big Bang. If verified, this link might provide a means of deciphering one of the biggest mysteries in the cosmos. Furthermore, the James Webb Space Telescope can research more than only black holes. It can also analyze exoplanet atmospheres in great detail. Through the examination of light passing through a planet's atmosphere as it approaches its star, scientists can detect chemical markers that signify the existence of water, methane, and potentially even traces of life. Because of its infrared capabilities, the JWST can see farther into the past than it has ever been able to, collecting light from the first stars and galaxies. This capacity offers a glimpse into the circumstances that gave rise to the universe as we know it now. aiding scientists in piecing together the tale of cosmic history. The interaction of black holes with the universe's structure is still a fascinating mystery as we push the limits of our knowledge. With every new finding that reveals a cosmos that is obviously more intricate and linked than we could have ever imagined, we get closer to understanding the fundamental essence of reality.